Yeah.
Hello, Professor. Okay, so I'm trying to find the area of the region bounded by r equals 7 cosine 6 theta. And since I know that there's going to be 12 petals in this rows, so I'm going to try, in order to find the total area, I'm going to solve for the area of one of the 12 petals and multiply by 12. And to solve for the area of one of the petals, I need to find the bounds. So like which angle, what the range of angle is for one petal. So when does cosine 6 theta become, or when does this function equal 0? When cosine 6 theta equals 0, we know that 6 theta is either pi over 2 or 3 pi over 2. So that leaves theta can be pi over 12, and theta can also be pi over 4. So we have the range for one of the 12 petals here, where this is, it would look like this. So we have the range for this petal here, and the formula for area will be area, or multiplied by 12, times the given formula 1/2 from pi over 4 to pi over 12, 7 cosine 6 theta squared d theta. And if we simplify that, we can get 6 And since we can't integrate cosine squared as is, first we have to convert it into 1 minus cosine 2, or 1 plus cosine 2x over 2. So this, we can also take the 49 out here. So 6 times 49 equals 1 plus cosine, and then 6 theta times 2 is 12 theta over 2. So this we can integrate, and then we can also take the 2 out, and then I'm gonna put it over here. Then this just becomes 3 times 49. So then we can simplify further, substitute the bounds in, and then when you substitute pi over 4 into this, then the total angle will be 3 pi, but then you can take out the 2 pi because it's cyclical. This conveniently cancels out. Then we just have pi over 6, 3 times 49 times pi over 6, which becomes 49 pi over 2. So that is the total area of the region bounded by r equals 7 cosine 6 theta. Yay! Okay. Now we have question 9. Find the length of the entire perimeter of the region inside r equals 20 sine theta, but outside r equals 3. So that will look something like this, and then the perimeter will be this or this larger area here with this smaller area that's on the outside, or larger perimeter here combined with the smaller perimeter on the outside of r equals 3 graph. So, okay. So first we find the intersection points here. And we can do that by setting them equal to each other. And then theta equals arc sine 3/20, and also pi minus arc sine. (3/20), and then we can say that the larger length is length 1 and the smaller length is length 2. And then I'll just say this is theta 1 and this is theta 2. So those are the bounds, and then the derivative dr/d theta is going to be, or dr1 over d theta will be 400 cosine theta, or 20 cosine theta, I mean, and then when you square that, it becomes 400 cosine squared theta. And then, oh, so length 1 is just, it's going to simplify really nicely. So then this becomes just 20 because sine squared theta plus cosine squared theta is 1 d theta. So then now we can move on to finding the smaller length, which is just going to become 3 times this. And when we add L1 and L2 to get the total perimeter, we can do 20 plus 3. (23 times theta 2 times theta 1. Now we can calculate what theta is. Okay. Oh yeah, okay. So these are our values for theta, and then I'm gonna plug that in the calculator. So this will be 0.1. And then this one will be and theta 2 minus theta 1 is 2.84, and multiply that by 23, and then you get 65.33 is the total perimeter outside of this, but, or yeah, the total perimeter. Okay.